But we like to keep it basic at the very beginning. So what are the key differences between, you got Haskell, Plutus, and Marlowe? And Plutus and Marlowe are domain-specific languages, right?
Haskell's a general purpose language like C++. So it's out there and people use it for writing all sorts of applications, from web-based things to intensive data analytics and so on. So as I say, it's like C++. I mean, what's different about Haskell is it's functional. And I think you've had other people on the podcast talking about this, perhaps Philip Wadler and Manuel Chakravarti. People have been thinking about functional languages for the last 30 years or so, and they have advantages in that you write in a very clean, clear, expressive, mathematical style. I think one reason they've been coming in more recently, one reason they've been getting traction is I think people, when you start writing applications, particularly multi-core applications in traditional languages, you run up against all sorts of problems of contention between threads when you have shared memory. So people have begun to think about what they call immutable data structures. So you don't program by changing values in variables. You program by thinking about data and how one piece of data relates to another. And this whole idea of immutability is right there at the basis of functional programming. The other thing that is key to functional programming is being able to have behavior as data. And that sounds really weird, if you like, but what's interesting is those ideas are sneaking into every sort of programming language. Java now has lambdas, JavaScript has lambdas, I think C++ might have lambdas. So a lambda is the way that you form these functions which become data. So the ideas of functional programming have gradually been spreading into traditional languages. And that means that people are they're getting a taste for this in something like JavaScript or Java or something like Scala. And they're saying, well, we want to do this for real. And lots of people are now migrating to Haskell particularly as a way of writing general purpose applications. So that's Haskell. Does that make sense? Are you happy with that as a starting point?
Yes, it certainly does. And I did a little bit of lookups on, and I went back to, it's wiki.haskell.org.
Right.
You can look that up, because often what people will ask is, what is Haskell used for? Does anyone else use it? Did IOHK invent this? There is a very large number of corporations on wiki.haskell.org that use the Haskell programming languages. Facebook is one of them, Alston Trading, there's banks, AT&T. AT&T is a very big company. There is an extremely large number of companies. If you want to look up more about that, check out wiki.haskell.org. It's used anywhere functional programming languages are needed. Google is on the list.
Yeah.
So there's
and there are quite a lot of people are using it and not talking about it, but that's another story. So so Haskell is there. And it's a language which gets people excited. So it's one reason for using Haskell, though not the primary one, is that you can recruit some of the top programmers. Because people who get excited by programming get excited by being able to use the best tools. And I think that's one reason that Haskell has come in as a tool of choice for IOHK. The other thing to say, and I think this underpins IOHK's general philosophy, is that Haskell, because it is more, inverted commas, mathematical, it's the programs that you write are closer to pieces of mathematics. They're not entirely pieces of mathematics, but they're closer. And so it's easier to write proofs about how they behave. So it's easier in principle to understand, to analyze the programs that get written, to prove properties of them. And this is something that IOHK has wanted to do, to build infrastructure that has a high degree of assurance built into the very development mechanism. And I think that's something that Haskell does support. You can take this, for example, work that the formal methods team have done is to use logic to describe aspects of the blockchain and then turn those into pieces of Haskell code in a way that you can see, here's the blockchain code, here's Haskell code, and they match very closely together. So it's easy to see how you get from the logical specification to the Haskell. So that's another reason for choosing Haskell. So Haskell's is general purpose language that runs on everything. Now, if you like, we then move to working on a blockchain platform. And when you move from writing a general purpose program to writing for blockchain, there are constraints on the language that you want to use. Hence, Solidity is a language that's designed to run with Ethereum, for example. Because in Haskell, you can write programs that can not terminate. You can write programs that run forever. You can write programs that consume large amounts of resources. And we don't want that to happen in a blockchain environment. Remember, these programs are going to be run by everyone who is running a node in Cardano. So people want to be able to write programs where they can understand how many resources they're going to use. They want to make sure that these programs will not run forever. You want to make sure that the programs won't cause particular kinds of errors or exceptions. So you want to write in a different sort of programming language, a slightly more constrained language. You also want the language to reflect what's going on in the blockchain. So it has to be able to be aware of things like slot numbers and so on. There's an abstract notion of time passing. So the language has to be different. And so Plutus has been designed as a language for writing general purpose computations on the blockchain. But the good news is that Plutus isn't an entirely new language. Plutus is really a version of Haskell. And so if you understand Haskell, you can write Plutus once you've understood its blockchain context. And that has a huge number of advantages because, for example, you don't have to write new editors. You don't have to write new profiling tools necessarily. These things come from the Haskell world. So we can reuse things that the large Haskell community has developed and reuse those for developing Plutus programs. And that's a difference from the Solidity world, where when you write Solidity, you write your blockchain application that runs on the chain in Solidity, but then you have to write a whole lot of JavaScript that runs off the chain to make the whole application work. So you've got something running on the blockchain and then perhaps code for the wallet that makes that integrates that program, makes it run in a way that users can interact with it. So within that world, you have Solidity plus JavaScript, two different languages. What we have in the Plutus world is it's Haskell producing both sides of that. So what runs on-chain, what runs off-chain, those are both Haskell code. So it provides a single view of writing an application rather than these two views that have to be then integrated. Okay, but so what we've got is this very nice version of a general purpose language that runs for which you can write general purpose programs on blockchain. But the disadvantage of that is you've got to be a programmer. So the story is, there's a nice story about what's the most widely used functional programming language in the world. Do you know the answer to this? It's Excel. It's the spreadsheet language, right? So there are 10 times as many users of spreadsheets as there are of general purpose programming languages. And what people do when they write spreadsheets is what they're really doing, if they're writing formulas and so on, they're writing things in a particular domain. So you can see Excel, or the way that people use Excel, as providing what's called a domain-specific language. You know, if you're working on a financial application in Excel, you'll be using financial terminology and so on. And what we've done with Marlowe is to say, well, what's the smallest language we can devise that is going to allow people to write financial contracts, like a simple loan, and run that on the Cardano blockchain. And we were inspired to do that by work that had been done nearly 20 years ago now in the financial sector, of saying, let's see how we can describe financial contracts in a way that's unambiguous and executable. And this was work done by Simon Peyton-Jones, among others, around the year 2000. And a number of investment banks and so on use this as standard technology. So what we thought, was let's take those ideas and see how we have to modify them if we're to run those contracts on blockchain and write contracts that are in a way self-enforceable. Because one of the differences between running things on blockchain in this permissionless, borderless world is that there aren't the legal backups that there would be from an ordinary contract. So you think you sign a contract for a mortgage or a loan or whatever, and that contract is underpinned by the legal system in the US or the UK or wherever. So if you don't pay, your counterparty can sue you. But if you want to do a similar thing on blockchain, you have to find mechanisms, and perhaps we can't always do that, but in lots of cases we can think about how to do that so that we can enforce the terms of the contract on the blockchain. And what we wanted to do was look at how we had to modify those contracts in order to try and achieve that. So that's what we've done with Marlowe, and what we're trying to do is to produce a language which is usable, like Excel. It's usable by a whole group of people who wouldn't want to write Haskell programs.